Hi everyone, today we'll go over some practice problems for circular motion and gravity. Starting out, a 2 kilogram object is tied to a string and swung in a horizontal circle with a radius of 1.5 meters. If the object completes one revolution every 2 seconds, what is the centripetal force acting on the object? Let's start by writing down the variables. So we know that the mass is 2 kilograms. The radius is 1.5 meters. And the period is 2 seconds because it completes one revolution every 2 seconds. Now, to find the centripetal force, we can use the formula. The centripetal force is equal to the mass times the velocity squared divided by the radius. However, we need to solve for the velocity first. And to do that, we can use the equation that the velocity is equal to 2 pi times the radius divided by the period. Plugging in the values we have, we get that the velocity is equal to 2 pi times it by 1.5 meters divided by 2 seconds. And this is equal to about 4.71 meters a second. Now let's plug this in to our formula for the centripetal force. So we get that the centripetal force is equal to 2 kilograms times it by 4.71 squared divided by 1.5 meters. And this gives us our answer of about 29.6 newtons. Our answer is given in newtons because we use SI units in the equation for the centripetal force, so the answer is given in the SI units. For this next question, a car of mass 1200 kilograms travels around a curve with a radius of 50 meters. The coefficient of static friction between the tires and the road is 0.4. What is the maximum speed of the car can travel without skidding? Now, to solve this, we're going to want the force of friction to equal the centripetal force, because if the centripetal force was larger, that would mean that the car would skid. So let's start by solving for the force of friction. To do this, the force of static friction is equal to the coefficient of static friction times by the normal force. Since we're on a flat surface, the normal force in this case is just equal to gravity, or mg. So that means that the force of friction will be equal to the coefficient of static friction times by mg. Now, let's write down the variables. We know that the mass is 1200 kilograms. The radius is 50 meters. And the coefficient of static friction is 0.4. So now, this means that to solve for the force of friction, plug in the variables, is equal to 0.4 times it by 1200 kilograms multiplied by 9.81 meters a second squared, because we're on Earth. This is equal to about 4,709 newtons. We know it's in newtons because we use the SI units in the formula, and the SI units of force is newtons. So this means that in order for the maximum speed of the car to not skid, the centripetal force will have to equal 4,709 newtons. Now, for the second part, let's solve for the velocity, where it'll cause the centripetal force to equal 4,709 newtons. So let's change the color to red so we can keep better track of what we're working on. If you recall, the centripetal force is equal to mass times velocity squared divided by the radius. Now we can rearrange this to solve for the velocity. And what we get is the square root of the centripetal force times by radius divided by the mass. And that is equal to the velocity. Now let's plug in the values that we've solved. So we have 4,709 newtons multiplied by 50 meters divided by 1,200 kilograms. And then we take the square root of the entire thing. And that gives us our velocity, which we find is equal to about 14 meters a second. So 14 meters a second will be the maximum speed that the car can travel around the curve without skidding. Now, for this next question, a satellite orbits Earth at an altitude of 300 kilometers above the surface. Given that the radius of Earth is 6,371 kilometers and the mass of Earth is 5.97 times 10 to the 24 kilograms, calculate the orbital speed of the satellite. We're going to want to start by finding the total radius of the satellite. To do this, we're going to add the radius of the Earth plus the distance above Earth's surface. So this is equal 6,371 kilometers plus 300 kilometers, which equals 6,671 kilometers. Now, we want to convert this into SI units, which will be meters. So if you recall, 1 kilometer is equal to 10 to the 3 meters. That means that our radius, our total radius for the satellite, is equal to 6.671 times 10 to the 6 meters, because we had 6,671 kilometers. Now, to find the orbital speed, we can use the orbital speed formula, which is that the velocity is equal to the square root of the gravity constant times the mass divided by the radius. If we plug in our values, this is equal to the square root. This is going to be a big equation, so it might be a bit messy. 6.674 times 10 to the negative 11 Newton meters squared per kilogram squared. Mass of 5.97 times 10 to the 24 kilograms. divided by the radius of the satellite, which is 6.671 times 10 to the 6 meters. And this gives us the answer for the velocity. Which is 7,730 meters a second, or about that. We can put this into kilometers a second, since the question asked in kilometers, we'll put it back into kilometers, which is equal to 7.73 kilometers a second. Now, for this next problem, we're supposed to calculate the orbital period of Earth rotating around the Sun. We've been given the mass of the Sun and given the mass of Earth and the distance between them. So there's a couple of ways you can go about this question. The way that we'll try to do this is to first solve for the velocity of Earth orbiting around the Sun, and then assume that it has a circular orbit, take the circumference, which will be the total distance Earth does in one rotation, and then divide the distance by the velocity to get the time. So, because the mass of the Sun is so much greater than the Earth, we can assume Earth acts as a satellite. So we can use the equation that velocity is equal to the square root, the gravity constant, times the mass of the Sun in this case, because it's the big one, divided by the radius. So putting these values in, we have 6.674 times 10 to the negative 11 Newton meters squared per kilogram squared. Times by the mass of the Sun, which is 1.98 times 10 to the 30 kilograms. All divided by the distance between them, which is 1.496 times 10 to the 11 meters. It's also known as 1 astronomical unit. And this leaves us with a velocity of about 29,712 meters a second, because we use the SI units in this equation. So this is an SI units for meters a second. Now, to calculate the distance Earth travels in one rotation, or one period, it's equal to the circumference, because we're going to assume it's a circle, which is just equal to 2 pi times the radius. So this goes to the distance it travels is equal to 2 pi times it by 1.496 times 10 to the 11 meters. And that is equal to about 9.4 times 10 to the 11 meters. Then the time for one period will just be the distance divided by the velocity. Because the distance that it travels in this case will be one full rotation. And this is equal to a little more than 31.6 billion seconds. Now, let's convert this into days. So, we think one day has 24 hours, which has 60 minutes and 60 seconds. So, one day equals 60 times 60 times 24. So converting our orbital period into days, you get an answer of about 366 days, which is just about 1 year. The reason why this is slightly off from 1 year is just due to rounding in the calculations.